My name is Luke Archambault. I'm a field application engineer at Microchip Technologies. In this video, we will be creating a complete TCP/IP project running on a PIC32MX device and running a local web server. We will also add a custom TCP/IP client socket that will connect to the Yahoo Weather API using a secure connection over SSL/TLS and retrieve the temperature of Phoenix in Arizona. The information will be provided over a USB CDC-class to a terminal application running on the computer. In order to achieve this, the video is divided into 3 sections. In section 1, we will be creating the TCP/IP project using MHC. In section 2, we'll be adding the USB console interface, and in the last section, we'll be adding the SSL library and the TCP/IP custom client applications. So let's start with section 1 by creating the TCP/IP project using MHC. First, we will be selecting the board support package. In our demo, we will be using the PIC32MX Ethernet Starter Kit. We will be adding the TCP/IP stack using one network interface. The PIC32MX 795 has an internal 10100 MAC. We'll be adding the HTTP server, which will serve the local web page. We will add simple network time protocol to allow the SSL library to validate the issue date and expiration date of the certificate provided during the NSSL connection. We'll be adding up drivers to configure the MAC and the PHY attached to the PIC32MX. We'll be adding the file system for the HTTP server to retrieve the local web page. And we'll be adding NVM or non-volatile memory to store that local web page onto the onboard flash of the PIC32. We will then be setting the PIC32 config bits with the various views for the operating mode of the device. And we will be using a utility to discover our device once attached or once connected to our local area network. Okay, let's start MPLAB X. So this project was created using MPLAB X version 3.0, MPLAB XC32 compiler version 1.33, and Harmony library version 1.04.02. The first thing that you'll need to verify is under Tools, Embedded, that you have the MPLAB Harmony Configurator installed. If it is not installed, you need to install it under the plugins. Once installed, go under File, New Project. Select the MPLAB Harmony project. Next. If it's your first time you're using Harmony, you need to set the path where the Harmony library is located. So if you browse to your computer, to the C drive, Microchip, Harmony, and in this case we'll be using version 1.04.02. We'll select that. We'll set the project name, Yahoo _ SSL, and the configuration name, Yahoo _ SSL. And then last, we'll be setting the device that we will be using. So in our case, it is the PIC32MX 795F512L, and then click Finish. While MHC is configuring your project, you notice that on the left hand side, the Yahoo SSL project is being created. So if I expand that, you'll see that multiple subfolders have been created under the project. If you expand these subfolders, no files yet has been added since we haven't completed our project. If you come to the middle tab, you'll notice that the MPLAB Harmony Configurator tab has appeared, which contains 3 subtabs. So the first tab is the option tabs. This is where we will configure all our project with the framework libraries, which is the TCP/IP, USB, and graphic libraries. The second tab is the clock diagram tab. So under this tab, this is a graphical interface that allows you to configure the internal oscillator to set it to 80 megahertz and setting the different PLL for the prescaler and postscaler to attain that frequency. And the third tab is the pin diagram tab, and which allows you to graphically again configure these pins to be input, output, or analog. So let's go back to the first tab. The first thing we will be setting in this first tab is the number of application. In our case, we will be only using one application since we're only using the Yahoo apps to connect to the Yahoo server. But if you have multiple applications that you need to run, this is where it will be set up. Then we will be selecting the board support package. So as mentioned, Microchip provides various demo boards, and here's an example of all these demo boards supported by Harmony. So if we click on the PIC32MX Ethernet Starter Kit, this is the one we will be using, and this is a picture of that demo board. This demo board, this starter kit, contains the full debugger on board, so nothing else is required to connect to MPLAB. Here's the PIC32MX795 with the Ethernet 10100 RJ45 jack over here. This is the debug port, so that connects directly to the debugger chip over here. And here are two USB connectors. The top connector is a USB host connector, while the bottom is a USB on-the-go connector, which we will be using as a USB device connection to the PC. This is connected to this PIC32MX over here. So if I move that away, so once the board is selected, then we will go into the Harmony framework configuration, and we will configure the first thing. We'll configure the TCPIP stack. So we'll select that. You will see that we have multiple check box already checked. So IPv4 is selected. We're using TCP and UDP. We're using ICMPv4 client. The Harmony TCP/IP stack supports multiple network at the same time. So you can have the PIC32 supporting one Ethernet and one Wi-Fi, or actually two Ethernet to two different network, or even more. So here's where we will set up the number of network. In our case, we will be only using one network, and here's the configuration for that network. So for that single network, we'll be using the PIC32 INT, or the internal 10100 MAC, but we could have selected the MRF 24W, which is our Wi-Fi module, or the ENCX24J600, which is a standalone 10100 MAC and PHY that can be connected over SPI or parallel interface to the PIC32MX device. So let's select the PIC32 internal, and let's provide a unique host name to our device. So Yahoo _SSL in our case. So here's that's all there is to be done for the network interface. If we scroll down, we will deselect the TCP console and debug service. So the TCP/IP stack provides its own console and debug services, but we will not be using it, as later on in section 2 we will enable the Harmony console interface. Again, we scroll down. We will be selecting the HTTP server because we will be serving a local web page. Over here, one thing needs to be selected is enable update via HTTP. This will allow you to actually use an HTTP post method to upload a new web page on the PIC microcontroller. So that's very convenient. If we scroll down, we're including the default HTTP custom template. So here's the web page, the default web page provided by the Harmony library. If you have your own web page, you will need to uncheck that or overwrite the one that's being provided in the project. So we'll leave it selected. Again, we scroll down. We're going to use SNTP. So we're going to check SNTP. Simple Network Time Protocol, which will provide the true date to the SSL library to validate the issue date and expiration date of the certificate provided by the Yahoo server during an SSL connection. The time protocol is enabled. And last, we will deselect the use TCP/IP command at this point because we will not have the console enabled yet, which is only enabled in the second section. So TCPIP commands is a method to provide to get or set information for the TCPIP stack over the console. But since the console is not yet enabled, we'll deselect that. So we are done with the TCPIP stack. So let's minimize this. Now that we have selected the stack, what is the driver? How do I interface to the Ethernet MAC? So you can see here there's various drivers, one for the ENC, one for the internal MAC, and one for the Wi-Fi. Since we have selected the internal MAC, if I expand that, you will see that it's already checked. There's only one thing here that needs to be changed, is actually the PHY that is attached to the PIC32. And in this case, the PHY is actually the national DP83848 PHY. So we will select this one. We are done with the driver for the Mac. Then we'll install the file system. So if I go into the system services, so let's minimize the driver. Let's go into system services. In the system services, we will enable the file system, and you will notice that it's already checked because we have enabled the HTTP server, which requires the file system to retrieve that web page. Few things to change over here. In the use file system service, multiple files need to be accessed at the same time or open at the same time. So let's set it to 25. And the second thing is to change the file system type. So there's only one file system type, but the local web page is served by the Microchip file system, not by the FAT file system. So it's a different format. So Microchip file system needs to be selected, and FAT file system needs to be deselected. So we're done with the file system. So now that we have the file system, where is that web page located? Is it into the internal flash? Is it into an external EEPROM? And this is where we will define under the driver. We will need to use the NVM memory. So we will use the non-volatile memory in order to store the web page. So it will be on the PIC flash. So we need to enable the use NVM. We will change the location of that page to be located at 0x9D07 and 40. So the last 64 KB of the 512 KB of that PIC32, and we'll reserve 64 KB for that location. If I scroll down, I need to enable the erase write function, and I need to register it with the file system. Enabling the erase write function allows you to actually update the web page over HTTP. If you do not select this, you will not be able to upload a new web page. And we are done with the NVM. So we've got the TCP/IP stack, we've got the file system, we've got the different drivers installed. Now we need to configure the device. So let's minimize the Harmony framework. If I expand the device and project configuration, PIC32 MX795 F512L, there are 4 configuration registers. The first one, the top one, the dev config 3. We need to set these to all off. For more details, please refer to the data sheet of the PIC32 MX795. Next config register, dev config 2. We will use the PLL input divider, set it to divided by 2. On the PIC32 MX Ethernet Starter Kit, there's an 8 MHz crystal. Divided by 2 makes it 4 MHz. We will then multiply it by 20, giving us the internal 80 MHz frequency. We will use the USB PLL input divider divided by 2, and we will not turn on the USB PLL yet, as this will automatically be enabled in the next session when we will use the console and the USB CDC class. But for your information, the USB PLL is a multiply by 24, so 8 megahertz crystal divided by 2, 4 megahertz times 24 is 96 megahertz for the internal USB frequency. And then the system PLL output clock divider divided by 1 to give us the system clock of 80 megahertz. Next register, dev config 1, we're using the primary PLL. On the board, there is a 32 kilohertz watch crystal, which is attached to the secondary oscillator. You can use it or not. In our case, we do not need it, so we'll turn it off. We will use the primary oscillator. Will be using XT, so the external crystal. The output off. The peripheral clock divider will be divided by 1, so the peripheral will be running at 80 megahertz, and the watchdog will turn the watchdog off. The last config register, nothing to change over here. So we are complete with the configuration bit. So what we need to do is actually generate our project. It will ask you to save it, which we will, and generate the project. So if you look at the project window on the left, multiple subfolders have been added, and actually files have been added. So under the header file, some under the app, there are other subfolders and files added. If I look at the source file and expand the app subfolders, you see all the files that the MHC has been adding to our project. So the app.c, which is our single application, MPFS image 2, which is actually the default web page loaded. Custom HTTP app is actually all the different functions that calls the dynamic variable served on that web page. And if I expand the framework, here's all the driver subfolders, the system subfolders, and the TCPIP stack subfolders to run the TCP framework. Once this is done, let's actually, before we program, let's open the app.c file. You can see that there's two functions in this file. The first one being app initialize. So at power up, this function is being called. This is where the application state machine, this is where the application state machine is being initialized, and this is where you will initialize all your variable or other functions that needs to be initialized here. And the second function is the app task. So in the main loop, the main while one loop, app task is being called periodically, and this is where you will run your state machine for your application. So this is the default. So for the purpose of this video, we are providing you the files shown on the link of this video. And if I go, here are the files. So there are 4 files provided to create that project. We need to copy these files. And if I go onto my computer under Microchip Harmony version 1.04.02 apps, you will notice that there's a new folder for our project that we just created. If I go in this project, firmware, source file, here are all the source file needed or created by MHC. We need to paste the 4 files over here. So I will copy the 4 files over here. I will overwrite the app.c and I will overwrite app.h, and the other files have been added. So if I go back to MPLAB X, so you can see that the file has been reloaded. So if I scroll down, the init file is the same. The app task is modified to the new application. The first thing I'm doing is in the init state, I'm mounting the file system. And once the file system is mounted, I'm setting up a periodic callback every 500 milliseconds to a function heartbeat, which will toggle the LED on the board every 500 milliseconds. Then it will change the state to the next state, which will be state run. And this states we will not be doing anything in this first section, but you can see that the app Yahoo task is commented out here, and that will be enabled in the third section of this video. Scrolling down again, here's a function for the heartbeat, which actually toggles the LED 3 on the board every 500 milliseconds. So now we are ready to program. So if I click on the Make and Program Device main project, the first thing it will ask me, if debugger has not been set yet, is to set it up. So under Microchip Starter Kit, Legacy Starter Kit, we will be selecting the SKDE PIC32. Click OK. And it is starting to build the project, and it will be programming the device. Programming the target device, and it's running the target device. So technically the demo board now is connected to my local area network. How do I know its IP address? If we go back into the MPLAB Harmony Configurator tab, if I minimize the device configuration, go back into the Harmony framework, TCPIP stack, there is a service which is called Use Announce Discovery Tool. This is a server running on it to the PIC that listens for an incoming packet with a specific string on port 3033. And when there's a request at that port, the PIC32 will advertise its IP address, MAC address, and host name to the requester or to the client. So Use Announce Discovery Tool was already checked and is actually active on this project. So if I go into, again, my computer, my C drive, Microchip Harmony version 1.04.02, there's a folder called Utilities, and there's again in this folder is one that's called TCPIP_Discoverer. There is an application, a Java application called TCPIP_Discoverer, and if I launch this application and click on Discover device, you will see that the PIC is responding. So this is a broadcast message with a specific information, and when the PIC receives that, it reply back with its MAC address, with the host name, Yahoo_SSL, with the MAC type it's using, so in this case the PIC32 ENT, and the IP address that has been assigned to that board. So now if I double click on the MAC address, it will launch my browser, and here's the web page being served by the PIC32. So this is the default web page served. So you can see the LED blinking every half a second here. Here's a random number being displayed by the application, and if I press on the button, you will see that the buttons are changing state right over here. So this concludes this first section. Now in section 2, we will be adding the console service. So we'll add the USB console, and we'll also configure the USB stack to provide the proper descriptor for that CDC class. And then we'll be connecting to the ESK32 over a terminal application running on my computer. So if I go back into MPLAB X, under the Harmony Configurator tab, if I expand the Harmony Framework configuration under the System Services, I will need to enable the console service. So I will check that. The first thing I need to change here is the console type will be a USB CDC console, and there's a note here saying USB CDC is currently not supported for static console mode, so we will change this for dynamic mode. Let's minimize it. If you look at the Harmony documentation, the console service can only be called by either the debug service, the command processor, or the file system service. In our case, we will use the command service, so I will expand that. Check that. That's all there is to do here. Now that we have enabled the console over USB, let's go into the USB library, and you will notice that it's already enabled. So if I expand this, the one thing I need to change here is the USB device instance 0. If I expand that, the product ID or the descriptor of this device needs to be changed to a CDC COM port single demo. If you do not set it up over here, that device will have no descriptor defined unless you provide your own, and then it will not enumerate properly on your computer. So CDC COM port single demo is a descriptor type. Now I can minimize this. The other thing we will change is if we go back into the TCPIP stack, now I can enable the use TCPIP command service since I will have the console enabled. So if I check that, I will have the various commands, so it will allow me to get and set information about that TCP/IP stack over the command terminal. Once this is done, this is complete, so I can minimize the TCP/IP stack. I can generate my code. I will save it and generate. So again, MHC is adding some files to my project. Now if I go under the source file framework and expand it, and now you can see that the USB framework has been added to my project. Now I can program the device. And now it's running the target. The chime that you just heard is actually the PIC32 enumerating to my computer. The application I will be using is CoolTerm. So if I launch CoolTerm, under the option tab, I can see that COM9 is already selected. So this is the only device connected to my computer. And if I hit the connect button and hit the return, now I'm getting the power up message from the stack being starting initialization and completing initialization. Now I can get over the TCP/IP command some information about the network. So if I type net info, I get all the information about the network setup. So the IP of my device, the MAC address of my device, the gateway, the DHCP is on. All these commands could be actually found into the project. If I go under source file, framework, TCP/IP, I expand TCP/IP and I expand stack, there's a file called TCP/IP commands. If I open that file and scroll down, you can see all the different command that is supported by the command TCP/IP. So we just did the net info, but there are other commands like DHCP to turn it on or off, set the IP, so I can actually set a static IP to my device once I have turned off the DHCP client on the device. I can ping other device, so if I go back, here's one we can try. If I go back onto the CoolTerm, I can actually ping microchip.com, so www.microchip.com, and it will actually resolve the IP address of microchip.com and then start pinging the web server. So 17 milliseconds to ping microchip.com, and that concludes that section 2. Now in section 3 we will be adding the SSL library. This requires more dynamic memory allocation to store the key and the certificate, so we will need to increase the heap by 20 KB. We will be adding the Yahoo Weather client application. These are custom files written specifically for this demonstration, so we will add app_yahoo.c, and we will be adding certs.h which is the certificate provided by that Yahoo weather server. We will then be sniffing packets using a tool called Wireshark. Wireshark allows us to view packets exchanged between the Ethernet Starter Kit and the Yahoo weather server. So if I go back into MPLAB X, under the MPLAB Harmony Configurator tab, the SSL library is provided to us by a third party, Wolf SSL. So if I go under the third party libraries, TCPIP, CASL or CYASSL, I need to enable that library. Here, nothing to change, just to mention that under the protocol and key exchange, the use of Diffie-Hellman protocol key exchange is very secure, but it's very computer intensive. So on a PIC32 MX running at 80 megahertz, this takes between 600 and 800 milliseconds to compute that key. So if you are regularly connecting to your server using SSL, you may decide not to use that protocol type. In our case, we will leave it selected because we're only connecting to the Yahoo server once every 10 seconds. So we're done with the addition of the SSL library. As mentioned, the dynamic memory allocation for the key and the certificate needs to be increased. So under the device and project configuration, project config, XC32, linker, and general, we need to increase the heap by 20K, so to 64 KB. And we are done modifying our project, so we can generate, save the project, and generate again. So under the projects tab, under the source file, now you will notice that the third-party folder has been added, and here is the CASL library folder with all the files for the SSL library. Few files to be added to our project. So under the header files app, I need to add existing items. So right-click on app, add existing item, and we need to add the certs.h, and under the source file app again, right click, add existing item, and add the app_yahoo.c file. Now I need to call that task. So if I go on the app.c file where my state machine is and scroll down to my state, app_state run, where I add the app_yahoo task commented out, and now I need to uncomment this, and at the end of the file there's a callback function that also needs to be uncommented. Now we're ready to program our part, so let's hit the program. Programming the target. And running the target. So the app Yahoo task is actually polling the Yahoo server every 10 seconds and getting the information of the temperature for Phoenix in Arizona and displaying it over the console terminal. So if I launch CoolTerm, connect, and hit the return, here you will notice that after the stack initialization, the CASL library is returning some errors, and the error -188 is actually the rejection of that certificate because it's unable to verify the issue and expiration date of that certificate provided by the Yahoo server. And the reason for this is that the SNTP task has not updated the time yet. And here is actually, if you look at a few lines down, here's a print of the SNTP updated, and this is actually a modification I did for the purpose of this demo, where I've added a printf in the SNTP state machine to print when the date of the application is updated. And you can see from this point on that when the application is connecting to the Yahoo server, the connection is successful and it retrieves the temperature of Phoenix, which is 93 degrees Fahrenheit presently. So if for some reason if your SNTP application is blocked by your firewall, you will keep getting error -188. So in order to prevent this, you can actually turn off the certificate validation. So if I go back into MPLAB X, open the file app_yahoo.c, and scroll down to the function that is called TCPIP_TLS_create connection. Here is where we are loading the certificate. And if I scroll down again, here is where I enable or disable the certificate verification. So in our case, it is enabled, so it SSL verify peer. But if your SNTP is blocked by your firewall and the SSL cannot validate the issue date or expiration date of the certificate, then it will reject it. So you need to set it to SSL verify none. And also, if you are unable to load the root CA that is signing that server certificate in the file certs.h, you may want to disable this, but this is at your own risk, obviously. Now we're ready to monitor or view the packet exchange between the Ethernet Starter Kit. So let me launch that tool called Wireshark. The first thing I will need to do is set a filter, and the filter will be on the MAC address of the Ethernet Starter Kit or any UDP packet coming in and out of the router, so 192.168.0.1. So this will allow me to view all these packets either from the Ethernet Starter Kit or from the UDP packet coming out of the router. So I will apply that filter. One thing to mention on my LAN setup is I have a switch with a mirror port which is connected to this computer. So any connection coming in and out of the Ethernet Starter Kit is also being copied on that mirror port, so Wireshark can view all the information. So before I start, let me reset that Ethernet Starter Kit. Also, make sure you close the browser that displays the local web page so you don't see all the communication between the browser and the Ethernet Starter Kit. Start and then launch the ESK. So here's the connection coming out of the Ethernet Starter Kit. So if I go back to the top of this capture, here is the request of the Ethernet Starter Kit for a DHCP Discover. So it's requesting an IP address. Here's the offer from the router, and here's the request for the offer. And here's the acknowledge from the router for this IP address. Keep scrolling down. Here's a UDP broadcast from the application Discoverer, which is running on our TCPIP stack, which broadcasts the IP address, MAC address, in MAC type of the TCPIP stack on port 3033. So any application can actually sniff this information and view the IP address. Keep scrolling down. Here's the DNS query to resolve the IP address of weather.yahooapis.com, and here's the connection to that server. Here's the SYN and SYNAC. So typical SSL connection, client LO, server LO. Keep scrolling down. You'll see here's the certificate, but you will notice that the socket is being closed right after that. And the reason being is that the SSL library is unable to validate that certificate because the time has not been updated onto the application yet. So it rejects that certificate because of the issue date and expiration date not matching the date on the TCP/IP stack. So if I keep scrolling down, there's another connection being attempted. Here's the certificate, and here's the socket again being closed. So let me scroll down until I see that SNTP connection. And here's that NTP connection. So Here's the IP address of the Ethernet Starter Kit requesting the time, and here's the response back from that time server. Next, here's the Yahoo task keeps trying to do a connection to that Yahoo server. So here's the connection, client hello, server hello. If I scroll down, here's the certificate, but you will notice that the socket is being closed again. And the reason for this is that even though the stack has received the response from the SNTP server, the application SNTP is made of multiple state machine. So until the date has been updated into the application, it takes several state. So that's why it's being rejected here. But if I keep scrolling down, here's the client hello, server hello, and here's the certificate. But now you'll notice that the client key exchange is happening. So that certificate has been approved, and here's the client key exchange, and here's the application data where the server is sending us the weather or the temperature of Phoenix in Arizona. And this is happening every 10 seconds. So this concludes this section, and actually this concludes this video. Thank you for watching.